We're gonna solve the following couple of inequalities. So we're gonna start with the inequality on the left, the parenthesis with x minus 6 multiplied by x plus 17 being greater or equal than 0. So to get moving, we start by multiplying the expression out. So we FOIL those two terms, and we end up with x squared plus 17x minus 6x minus 102. Being greater or equal than 0. So if we combine like terms, we have x squared plus 11x minus 102 being greater or equal than 0. So the solution of this inequality will be where the graph of y equals x squared plus 11x minus 102 is exactly on or above x-axis. And this comes from the inequality being greater or equal than 0. So this gives you on or above statement. And and the graph of x squared plus 11x minus 102 is a parabola that opens up. So to have the relationship of the parabola with the x-axis exactly right, we figure out the x-intercepts. So we said x squared plus 11x minus 102 equals 0. But this is equivalent to the original x minus 6 times x plus 17 expression. So this factors into x minus 6 times x plus 17 equals 0. So we get one solution, x equals 6, and the other solution is x equals negative 17. So those two numbers will be the x-intercepts. So now we have all the information needed for the sketch of the graph of the function. So this is our x-axis, so those are the two x-intercepts that we have found, negative 17 and positive 6. And we said that the graph is going to be the parabola that opens up, so this red curve is the graph of the parabola that opens up. Now we said that the solution to the inequality will be where the graph is on or above x-axis. And so the graph is on or above x-axis on this left interval to the left of negative 17. And then another piece where the graph is on or above x-axis is to the right of x equals 6. So those are the two intervals that are going to end up in the solution. And in the interval notation, they look like the interval from negative infinity to negative 17, union with the interval from 6 up to the positive infinity. In a similar way, we can work on the inequality on the right. So we have those two parentheses multiplied together being greater than 0. So if we multiply those two out, you just directly FOIL it. You get 6x plus 102 minus x squared minus 17x being greater than 0. And if you combine like terms, the left-hand side simplifies to negative x squared minus 11x plus 102. So solution to this inequality will be where the graph of y equals negative x squared minus 11x plus 102 is exactly above x-axis. And again, so this inequality being greater than 0 gives us the above the x-axis statement. So as far as the graph of y equals negative x squared minus 11x plus 102 goes, it is a parabola that opens down. So it opens down because there is a negative in front of x squared. And if we look for the x-intercepts, we're going to be solving negative x squared minus 11x plus 102 equals 0. So we know that it factors into this original expression. So it's the same as 6 minus x times x plus 17 equals 0. So if you set 6 minus x into 0, this is the same as 6 equals x, if you add x to both sides. So the answer is x equals 6. And likewise, x plus 17 equals 0 gives you x equals negative 17. So those are the two intercepts. So you set up the x-axis, the two x-intercepts, and the parabola should be opening down, so that's your upside down parabola. And we're looking for the places where the graph is strictly above x-axis, so it's going to be the interval between -17 and 6. That's where the graph is above x-axis. So for the answer, we're going to get the interval between -17 and +6 with the parentheses, because the inequality is the strict inequality. We're going to solve the following two quadratic inequalities. We'll start with the inequality on the left, the x squared plus 2x plus 1 being greater than 0 inequality. So as usual, we take the graphing approach to the solution. So solution of this inequality is where the graph of y equals x squared plus 2x plus 1 is above x-axis. And the graph of y equals x squared plus 2x plus 1 is a parabola that opens up. And the parabola opens up because we have a positive x squared coefficient. And you're choosing the places where the graph is above x-axis because you have the greater than 0 inequality. So since you have greater than 0 inequality, you have the above x-axis statement. Now, since we would like to know where the graph crosses x-axis, we find the x-intercepts of this graph. So you set x squared plus 2x plus 1 equals 0. So this one factors easily. You get x plus 1 times x plus 1. And you get two solutions that are exactly the same numbers, x equals -1. So what you end up with, you're going to end up with exactly one x-intercept for the parabola. And the parabola is opening up. So the only way for the parabola opening up, having a single x-intercept, is when it actually sits exactly on top of the x-axis. So that's what I was trying to draw here. It's a parabola that sits on top of the x-axis. So if you look for the intervals where the parabola is strictly above x-axis, it's going to be all the points except for the x equals -1. So with the exception of x equals -1, all other x values give you the graph being above x-axis. So for the answer, you get the two intervals, one from -infinity to -1 with the parentheses, and another interval from -1 to +infinity. Now if we move on to the second inequality, so we're trying to solve x squared plus 1 being less or equal than 0. So if you take the graphing approach, so since you have the inequality less or equal than 0, so this means that the graph should be on or below x-axis. So that's what I have written here. So we're looking for the places where the graph of y equals x squared plus 1 is below or exactly on x-axis. So, and the graph is going to be a parabola that opens up. And if we look for the x-intercepts of this parabola, you're looking on the equation x squared plus 1 equals 0. That gives you x squared equals -1. And if you take square root of both sides, you're looking on x being positive or negative square root of -1. And square root of -1 is not a real number, so we don't have any real solutions to this equation. So since we have no real solutions, there are no actual x-intercepts for the graph. So to make a believable picture, so this is the x-axis. We want to draw an upright U-shape that doesn't touch or cross x-axis, so it should be above x-axis all the time. So that's what I represented here. It's some quadratic function that is above x-axis. Now remember, so we're trying to solve inequality x squared plus 1 being less or equal than 0, so we're looking for the places where the graph is below or exactly on x-axis, and there are no such places. So for the answer, you're going to get an empty set that is denoted like this. And if you have to enter it online, you can enter it as a curly brace, a space, and another curly brace. That's the online notation for the empty set. We're going to work on solving this quadratic inequality, x squared being greater or equal than 48 minus 8x. So to start working, we're going to move all the terms to the left-hand side so that there is a 0 on the right-hand side. So you're looking on x squared minus 48 plus 8x being greater or equal than 0. So if you rearrange the terms, this is inequality x squared plus 8x minus 48 being greater or equal than 0. And so we take the graphing approach, and since we have the greater or equal than 0 signs, so it means that the graph should be on or above x-axis, above x-axis. So I'm talking about the graph of y equals x squared plus 8x minus 48. And the graph of that function is a parabola that opens up. So it opens up because the x squared coefficient is a positive. The x squared coefficient is positive 1. All that we need to figure out the x-intercepts. So to solve for x-intercepts, you set x squared plus 8x minus 48 equals 0. Okay, so that factors into x plus 12 times x minus 4 equals 0. So, and you get two solutions, x equals negative 12 and x equals positive 4. So we're going to be drawing a parabola that opens up and has those two x-intercepts. So those are the two x-intercepts. This is the parabola that opens up. And we're looking for the places where this parabola is exactly on or above x-axis. So this is this left piece and that right piece. And for an answer, we're going to get interval from negative infinity to negative 12, union with interval from 4 to positive infinity. And then negative 12 and 4 have brackets because this is a non-strict inequality. So the x-intercepts are included in the solution.